Hey everyone, I'm Said and welcome back. In this video, I'm gonna solve some more partial fractions problems, but this time they're gonna be more challenging. Let's get started. Number 1, the integral of 5x minus 1 over x minus 1 whole squared dx. In this problem, the factor x minus 1 is repeated twice. But why does this matter? Because we need a term for every power of the factor up to its total degree, right? So we have 5x minus 1 over x minus 1 whole squared equals a over x minus 1 plus b over x minus 1 whole squared. Now multiply by x minus 1 whole squared to get rid of the highest power in the denominator. So we have 5x minus 1 equals a times x minus 1 whole squared over x minus 1. So the x minus 1 terms cancel out. So we have a times x minus 1 plus b times x minus 1 whole squared over x minus 1 whole squared. So the factors of x minus 1 whole squared cancel and we have b, or ax minus a plus b, right? So we have 5x minus 1 equals ax minus a plus b. Now compare coefficients of x. We have a equals 5 and negative a plus b is negative 1. Negative a plus b is negative 1 and we know that a is 5, so negative 1 plus 5 is 4. So b is 4. So the integral becomes the integral of a over x minus 1 plus b over x minus 1 whole squared. A is 5 over x minus 1 dx plus the integral of b is 4 over x minus 1 whole squared dx. The derivative of x minus 1 is dx. So we have 5 times, since the derivative of the denominator appears in the numerator, the integral is the natural log of the denominator. So we have 5 ln of the absolute value of x minus 1 plus the integral of 4 times the integral of dx over x minus 1 whole squared. So we have 5 ln of the absolute value of x minus 1 plus 4 times the integral of dx over x minus 1 whole squared equals the integral of x minus 1 to the power of negative 2 dx. And if we use the power rule, we have 1 over negative 2 plus 1 times x minus 1 to the power of negative 2 plus 1, right? And final answer is 5 times ln of the absolute value of x minus 1 plus 4 over negative 2 plus 1 is negative 4 times x minus 1 to the power of negative 1 means 4 over x minus 1 plus c. Number 2, the integral of 1 over x times x minus 1 whole squared dx. We have one simple linear factor x and one repeated factor x minus 1 whole squared. So we have 1 over x times x minus 1 whole squared equals a over x plus b over x minus 1 plus c over x minus 1 whole squared. Now we multiply both sides of the equation by x times x minus 1 whole squared. So we have 1 equals a times x minus 1 whole squared over x. So x terms cancel out and we have a times x minus 1 whole squared, right? Plus b times x minus 1 whole squared over x minus 1. So the x minus 1 terms cancel out and we have b times x minus 1, right? And c times x minus 1 whole squared over x minus 1 whole squared. So the x minus 1 whole squared terms cancel out and we have plus cx. So for example, if x equals 1, so we have 1 equals a times 0 and b times 0 because x is 1. So here is 0, here is 0, and here is c. So c equals 1, right? If x equals 0, so we have 1 equals a times 0 minus 1 is negative 1 squared is 1. So we have a plus b times 0 is 0 and c times 0 is 0. So a equals 1. And if, for example, x equals 2, so we have 1 equals a times 2 minus 1 is 1. So a plus 2 minus 1 is 1 times 2 is 2. So here is 2 times b, 2b plus 2c. And we know that a is 1 and c is 1, right? So 1 equals 1 plus 2b plus 2. So 2b equals negative 2. So b is negative 1. So the integral becomes the integral of a over x means 1 over x plus b is negative 1. So negative 1 over x minus 1. So negative 1 over x minus 1 plus c over x minus 1 whole squared. C is 1. So 1 over x minus 1 whole squared. 1 over x minus 1 whole squared dx. So final answer is dx over x is ln of the absolute value of x minus dx over x minus 1 is ln of the absolute value of x minus 1 plus, and the integral of dx over x minus 1 whole squared, we use the power rule. We have the integral of 1 or dx over x minus 1 whole squared equals the integral of x minus 1 whole squared dx, negative 2, right? So u is x minus 1, so du is dx. So the integral becomes u to the power of negative 2 du. And if we use the power rule, we have 1 over negative 2 plus 1 is negative 1 u to the power of negative 1, or negative 1 over u, or negative 1 over x minus 1. So we have negative 1 over x minus 1 plus c. The integral of x squared plus 3x plus 2 over x times x plus 1 times x plus 2 dx. Before jumping into partial fractions, always check if the numerator can be factored. Notice that the integral of x squared plus 3x plus 2 is x plus 1 times x plus 2, right? Over x times x plus 1 times x plus 2 dx. So the x plus 1 and x plus 2 terms cancel out, and we have the integral of dx over x. So we have the integral of dx over x is ln of the absolute value of x plus c.